Hello everyone. So today I will be demonstrating how to create a working, partially reconfigurable design using the PlanAhead software from Xilinx. PlanAhead does not support projects using HDL, so in order to do this tutorial we must first synthesize our design. According to the provided tutorial, we can synthesize our design using the tclsh command and the scripts provided in the tools folder. First we are told to move to the implementation directory so the output will be generated there, and then we are to run the following scripts. An important thing to note is that when synthesizing your own projects, all access to project files default to having I/O buffer insertion turned on. However, when creating your own design, you must turn this off during the synthesis of all non-top level modules. So, at first I tried to use the tclsh command, but in 12.4 it appears there is no tclsh command. It's been modified to xtclsh. So even though the Xilinx tutorial doesn't mention that, be sure to use xtclsh in order to synthesize. So first we're going to create a new project. Let's see the default name. We click set PR project and you specify synthesize netlist. You need to select the top netlist file, which is an implementation under the folder top. And then we go to next, and then we pick the constrained file, which is in the UCF folder under sources. Oh, great, I accidentally clicked the wrong button. Under downloads, right? Yeah, here we go. And source and UCF. Then load the UCF file and click next. It automatically defaults to the correct device we wished for. And we're not going to save the prior attempt at this. It'll create a project. Will then take us to the project manager page where we can see the two files that have been included so far. By clicking on netlist design, it will populate the netlist so that we can take a look at what's inside those files. It'll also load the device view so that we can actually see some errors reading constraints. I see. Because I already modified the constraints and added the things that they wanted us to add earlier. However, that's not a big deal. So the first thing we want to do is to right-click on U1 Reconfigurable Partition, put blockgram, and click Select Partition. This allows us to create a reconfigurable partition. Showing name, blockgram. I forgot what the names are that they suggested we use, but it doesn't actually matter, but VRAM first and VRAM second. VRAM first, we use the netlist already available, and we just pick out the netlist by going to the folder VRAM first. Oh wait, this is the source folder under implementation and loading the ngC file. You don't need any special constraints for this module, so we just finish and import it. We then do the same thing for RP count. We click select partition. You can save before that, but that's not important. And then we click next, and we name this count CW, and we go to the count CW folder, and click next, and finish, and we add that module. So our next step is we can actually add more reconfigurable modules by right-clicking on them again. We can add reconfigurable module. So we're going to add VRAM second, and load the ENGC in the same way that we did earlier. And then, as you can see, it adds a reconfigurable module under there. However, we still need to add the other reconfigurable module for the count device. So we add count CCW, the alternative count module, and we go and find that. Now, after implementing all these, you can see that we can take a look and see what's inside the various modules, like our block RAM obviously has a block RAM, while the count has a bunch of primitives, mainly consisting of slice logic and then some output buffers. As you can see. Well, I know there's supposed to be output buffers in here somewhere. Ah, there they are. But anyways, we're now going to select count CW, make it right-click on it and click Set as active reconfigurable module. And we're going to select VRAM first and make it our active reconfigurable module. Next goal is to set the AG range. The AG range basically just tells the bitstream generator where the boundaries of these of the static regions are, of the reconfigurable regions are, and the rest of the design is considered static. So in order to create the AG range, we first click on physical constraints, and then we right-click on block RAM or count. In this case, I'm going to choose to do count first. But first, since I'm running as low resolution, I'm going to close these to try to make things a little bit bigger, or easier to see rather. So, in this case, I want to place the module, which, as you can see, it's already kept the placement from the last time I did this. However, because it's stored in the UCF file. However, just for the sake of demonstration, I'll explain how I did this. You Control F, and it'll actually find various sites. So I use this to find the sites that were listed in the tutorial. For example, the tutorial said that we wish to have AH27 inside our module, because for the count module there are already output pins defined inside the UCF file, so we need to include those when we're creating our PBox, which is the box boundary region that confines the area that's reconfigurable. So if we click mark after finding this input-output block, it'll mark it, and that's how I made sure that the box circles the marks. So I can actually just clear this, but I should probably keep track of where the boundaries are. We'll just say down to there, to that red box. But so if we were doing this from scratch, there wouldn't be a box. So I'll just clear this rectangle. And then you would hit set PBox size and select from here up to the marker. And you'd pick slice IOB. I believe it's IOB if I'm remembering correctly. Yeah. And hit OK, and it will be fine. And I did the same thing for the block RAM. The block RAM is just, it doesn't have anything particular in it. It just needs to have some slice logic and enough block RAM to contain the necessary logic. So it doesn't really matter where you place it, but closer makes routing easier, I guess. Select slice and RAM block R36. And so now we have it. These constraints get added to the constraints file. If we expand this and go back to Project Manager and open up the UCS file, we'll see that these constraints are contained under an area group that is placed at the bottom. The next step was to add some timing constraints to the design, which we can do by going to Netlist Design and clicking on Timing Constraints. I've already added them earlier, so I'll just delete them so that it's asking whether I want to. Instead, we'll pick New Timing Constraint, and we'll go to Basic Group and select the group name Clock P and set it to Net, TMNet, and name the net Clock P and hit OK. You then right-click and create another new timing constraint, which is time spec period, which we name TS Clock P. We set the period to 5 nanoseconds. These timing constraints constrain the interfaces of the reconfigurable design. And you then select group and pick group constraint type user defined. Okay. And now that we've added these two constraints, we'll save the design.